Hello, this is Mr. Flatness, and today we're going to be looking at reviewing adding and subtracting decimals. The most important thing to remember when adding and subtracting decimals is to line up your decimal points. So a lot of times textbooks, they write the problems in a horizontal fashion where they go across the page, and so for me to solve it, I need to rewrite the problem vertically, and when I do that, then I can line up my decimal points. So for problem number 1, I will write 6 and 852 thousandths. I will add that to 3 and 2 tenths. Notice I don't have any numbers behind the 2, so what I do there is I'll add a 0 just as a placeholder. 3.2 is the exact same thing as 3.200, so now I can add up my columns like I normally would. So adding this up, I would get 2, 5, 10, and 10, and then don't forget to put the decimal straight down in your answer. Again, that's why we want to line up the decimal points, because now I know I'll place the decimal point correctly in my answer as well. I can also take a look at estimation. 6.8 is really close to 7, and 3.2 is close to 3. 7 plus 3 is 10. Well, notice my answer, I'm very, very close to 10. In the next example, we have a subtraction problem, and that's another thing. Be very careful that you look at the sign. A lot of times kids make errors simply because they go too fast and they don't pay attention to the sign. So looking at the problem, we have 12 minus 3.67. Anytime you have a number where you don't see a decimal point, you assume then that the decimal point comes right after. So I'm going to put the decimal point right after 12. And again, I'm going to add in my zeros as placeholders. Now I can go ahead and solve. My decimal points are lined up. So notice I can't take 7 away from 0. So I'm going to have to go all the way over to here and borrow, so that 2 take away 1, I'm going to borrow 1 from that, and so that's 10 tenths. And then I'm going to take 10 tenths and borrow a tenth away, and now that becomes 10 100ths. So now I can subtract. 10 take away 7 is 3. 9 take away 6 is 3. Put that decimal straight down. I can't take 3 from 1, so I'll borrow one more time. And we have 11 take away 3 is 8. And again, I can use estimation. 12 take away 3 is roughly 9. And so 12 take away 3 is 9, and 8 is very, very close to 9. So therefore, I know that I'm on the right path. I can also take the skill of adding and subtracting decimals and add into it a different concept called expressions. And expressions, all they are is just mathematical problems in where you're going to see operations. I see add and I see subtract. But notice now I have numbers and I also have letters. Okay, these letters are called variables. And variables are just letters that stand for a number. So notice to the right of this, I know that R is 2.14. And I know that T is 4.359. The bottom, or the last decimal point there, that's not a decimal point, that's an actual period. So taking a look at this, I would need to solve this problem in a particular order. I have addition and I have subtraction, so I'm just going to work this problem from left to right. So I'm going to start out by taking 6.7. Now I'm going to add in now what R is. R is 2.14. And then I'm going to subtract T, which is 4.359. Okay, so I'm going to rewrite the problem first and double check to make sure that I have the appropriate number for the appropriate letter. So now that I have that, I can solve. So I'll start out by going 6.71 plus 2.14. Adding that together, I will get 8.85. I'll just double check it one more time. Looks like that's correct. And then I'll take that 8.85 and now subtract 4.359. Notice I'm going to have to put a 0 in here as a placeholder, and then I can use borrowing. 10 take away 9 is 1. I'll have to borrow again. 14 take away 5 is 9. And then we have the rest of it. So my answer in this expression would be 4.491. Again, I can use estimation. 6.7 is close to 7. 2.14 is close to 2. 7, 2, 4.3 is 4. Okay, so 7 plus 2 is 9. 9 take away 4 is 5. Okay, and 4.4 is very, very close to 5, so I know that I'm doing this problem correctly. So as you can see, estimation is a very valuable tool because it can help you eliminate mistakes if you go too fast in any particular problem. So I don't have to worry about the exact sum to check my answer. I can just get it close by rounding. So a lot of times, notice when I rounded to the leading digit, and then I added afterwards. So what is a leading digit? A leading digit is the first digit in a number. So taking a look, I have $8.43, so 8 is the leading digit. 661, 792, and 21. So I can estimate this problem and come up with a very quick answer. To go and review the rules of rounding, remember, if the number to the right, so if I'm going to round to 8, I need to look at the 4. If this digit is 5 or higher, the 8 goes to a 9. And then these two numbers go to 0. If it's 4 or smaller, then I'm going to keep the 8 as it is. So that would apply here. 6, I'd have to round that to a 7. Looking at the 9, that would change that to an 8. And 21, the 1 would keep that at 2. So rewriting this, it would be 8 plus 7 plus 8 plus 20. And then I can add them up. So, and because they're all add, I can do this quickly in my head here, because if all your numbers are addition, it doesn't matter the order that I work with this problem. So I see 2 8s, so I know that's 16. Then I can take a look at 16 and 20, well that's 36. And 36 plus 7 is 43. So that would be an estimated answer to the very first problem. Press pause right now and you try the next one using estimation. Then you can press play to check your answer. 6.7 is going to round to 7. 2.37 is going to round to 2. 5.2 is going to round to 5. Notice there's subtraction in there, so hopefully you picked that out. So 7 plus 2 is 9, and 9 take away 5 is 4. So your estimated answer should have been 4. The final concept I'm going to review with you is called expanded notation. And expanded notation is just taking a number like 268.374 and just breaking it apart into all its different parts. So in order to do this, you need to know place value. So looking at the decimal point, you need to know that the number to the right of that is in the tenths place. This next number is in the hundredths, and the third number is in the thousandths. You need to know that any number left of the decimal point is in the ones, tens, and hundreds. So for an expanded notation or expanded form, I'm going to just break it down. 2 is in the hundreds place value. So I have 2 groups of 100 or 200. I have 6 groups of 10, well that's 60. 8 ones, 8 times 1 is 8. Then I have 3 tenths, so I can write that as 0.3. I have 7 hundredths, so notice I can write that as 0.07 or 0.07. These zeros you can either use or they're not necessary, you don't need to have them there. And finally I have 4 groups of 1,000 or 4 thousandths. So this particular number right here would be in an expanded form. So press pause. I'm going to give you a problem to try on your own and see if you can write this number in expanded form. Let's try 341 and 16 thousandths. So breaking this number down, I have 3 groups of 100 for 300. I have 4 groups of 10 for 40. I have 1 group of 1. I have 0 tens. I have 100, hundredth, should say, and then I have 6 thousandths. So looking at it, here is your answer right here. Another thing to do would be to try this problem backwards, where instead of giving you the standard form, I'm going to give you the expanded form, and let's see if you can turn it back into standard. So I'm going to say 200 plus 4 plus 7 tenths plus 5 hundredths plus 3 thousandths. So looking at this, I have 200, well that's 2 groups of 100. Notice I don't have any tens, and I only have 4. So 200 plus 4 is 204. Notice now I get into the decimal point, so now I'm going to put in a decimal point. So now I have 7 tenths, I have 5 hundredths, and I have 3 thousandths. So that's 204.753. This concludes our lesson on adding and subtracting decimals along with expanded notation.